How's it going, folks? Jack here. So on this channel we watch a bunch of fun stuff, but occasionally we do tap into the scientific realm, especially with crazy YouTube scientists. We've come across the likes of I Did a Thing from the Australian side of things, Michael Reeves through computing, to put it lightly, and there is one whom I think about sometimes, one of the OGs that I just tend to forget about, but is always much appreciated whenever I remember of him. Styropyro. Yes, the man, the myth, the laser shotgun. And so on today's video, he straps 100 batteries wired in parallels, and I know as much as lasers are his MO, I want to see... I'm sorry, the thumbnail is killing me. I want to see what he's gonna achieve when he does the very thing that we are told as children not to do: play with batteries.
This video is sponsored by AnyDesk. You ever wake up in the morning and ask yourself, what happens when you wire 100 car batteries in parallel? If so, you're in luck, because that's exactly what I'll be doing today.
The posture, the whole attitude and the way that he always carries himself is wonderful. It makes me so giddy, but at the same time it's like, what are you doing, mate?
By wiring all these in parallel, the voltage is going to be the same as a single battery, which is just a bit over 12 volts. Now I realize this seems lame compared to what I usually show on this channel, but you see, this isn't a video about high voltage.
Amps.
Oh no, we're playing with fire today. See that rating right there? That's how much current this battery can deliver for 30 seconds in freezing temps.
I mean, it was pretty much a given as soon as you could see that the title mentioned in parallel, right? Because, yeah, when we're talking DC here, it's the current that we're looking for.
And that's 850 amps. So, by wiring 100 of these in parallel, we're looking at 85,000 amps. Of course, cable and contact resistance is going to limit that somewhat, but I'm curious to see just how ridiculously high the current can get here.
That's insane. Mind you, I mean, just the setup.
That somewhat. But I'm curious to see just how ridiculously high the current can get here.
He said 80,000. A lightning strike, to my knowledge, is about 30. That's a whammy.
I mean, it's one thing to produce thousands of amps for a tiny fraction of a second. But what does it look like when you make even more than that over a few seconds?
I've blown up a few light bulbs like this in a lab before. Mind you, electrical wiring or anything of the sort is not my area of expertise, okay? I kind of know how to follow certain guidelines and or how not to in the cases where I blow up light bulbs.
In fact, I'm hoping to achieve the current seen in a lightning strike with these batteries.
Right.
The most daunting engineering task for this project was coming up with a way to switch these massive currents, particularly one that can break the circuit when tens of thousands of amps are flowing through it. I settled on modifying a log splitter, mostly because it can rip apart contacts that weld themselves together. Now the best part about this switch is that you load it like a crossbow. Let me show you this beautiful mechanism here. So I gotta yank this back while feeding it this pin. It's not very easy. Let me just show you. Okay, so now it's loaded, and I have to feed it this actuator so it can yank out that pin. Let me just show you.
This man has strapped the setup of like a battery room that you will usually find in, like, I don't know, like a hospital or something of the sort, that are usually controlled by an industrial mechanism where he just has it loaded like a crossbow. That's wild.
You can see the actuator there that yanks out that pin. So now, when I hit this yeet switch...
The yeet switch!
The contacts slam together. And then if I have some catastrophic failure and need to kill power, I just press this frick button here to rip apart those plates.
Oh my
and I also
god.
have to yank the string at the same time.
Oh, okay. If he ever opens a company, I will send my application just so that we can create unconventional nomenclature for different devices.
Seems safe enough, right? Now, I don't want to bore you with numbers.
Okay.
I feel like it's important to give you a sense of the crazy scale that I'm dealing with here. That bank holds an incredible 320 megajoules of energy. That means that if one of those batteries fails short, The energy equivalent of 500
Oh.
cars screaming down the highway would get dumped into it all at once.
I would have wondered as well, how many kilotons of TNT are we talking about here? Gonna turn his backyard into a freaking crater site. Poor trees.
Which would probably make a sizable crater. I really
Yeah.
hope that doesn't happen. Now I could go on and on about how clinically insane this is.
Stop.
I should let the rest of the video do the talking here.
This man is so close to asking you to paint him like one of your French girls. That's the posture. I can't.
I will say that you definitely shouldn't play with car batteries. I mean, even one can mess you up if you abuse it enough. So yeah, don't try this at home. For the first test, I'm going to try a piece of 1/4-inch threaded steel rod. This should be easy to melt, but the small size will probably limit the current somewhat.
Oh.
It looks
Oh. Okay.
like the connection broke there. I mean, it is only 12 volts, so nearly anything can break the circuit here.
Yeah, I want
I
some
went ahead
green
and snapped
light.
the threads with a hammer a bit to hopefully give more area
For
of
the zinc.
contact.
Well, yellow smoke. Close.
It was slower than I hoped, but I did like the green flames from the zinc plating burning off. Here I have a 3/8-inch threaded rod. Now this has over double the area of the last rod, so it should pass quite a bit more current.
See, there's a reason why this setup is happening outside and not indoor. Like, I alluded to the use of a battery room before, and the thing about them is that they often make use of like hydrogen management, right? Because a thing that you want to avoid is electrostatic charges building up in any way whatsoever, because a battery, as long as they are not used, they will produce oxyhydrogen gas, which can cause an explosion, right? If there is sparking involved, which is one of the reasons why this is happening outside. So the battery management rooms usually have like dissipating floors to make sure that that buildup doesn't happen, and of course they are always well ventilated.
So it should pass quite a bit more current. Here we go.
That's so...
Look at that. Wow.
Could make for a quick way to make a new anvil.
Cool. I think that one was just as fast, if not faster. Let's try zapping some ferrocerium. Now, this is the metal alloy
Sparks
that makes
for
a fire
days.
lighter flints. And it makes a bunch of sparks when it's ground down. I'm hoping it makes even more sparks with these batteries. Here we go.
Oh yeah, it did.
It just exploded.
Damn, those
Maybe a
cameras.
bigger rod will give even more sparks. There we go. Ha! I'll take that as a yes. Unfortunately, it didn't actually burn all the way through there.
Does he
Gosh,
have
it's
a...
just so hard to keep contact with the voltage being so low. You guys just need more weight. This is a kilogram ingot of bismuth metal.
I'm sorry. I know that a lot of this is premeditated, right? Because obviously he's not just gonna pull this out of nowhere, but still, the transitions are genius. Ain't no way that somebody just carries, well, okay, perhaps he does, but just carries like a kilogram of bismuth like out of their pocket.
It's super dense and melty, so I'm hoping it will keep enough contact to melt all the way through.
Ah,
Well, that was messy. It splattered molten metal all over the place, although a lot of it was unmelted. It still made a nice puddle, though. Plus, the oxide layer on the remaining ingot is super colorful.
yeah.
I want to try zapping this 1/2-inch bolt, but this time I'm going to measure the current through it by looking at the voltage drop across the cables.
Oh no.
Here we go.
Nice.
Yes! It took a while for it to secure contact, but once it did, it melted pretty quickly. The oscillogram is noisy, but once it made full contact, there was a drop of about 180 millivolts there. Now this is across a mere 16 millionths of an ohm. which means the current there was about 11,000 amps. Not bad. Let's give this saw blade a try. It's nice and flat and conductive. It should pass a substantial amount of current. Flat and conductive, it should pass a substantial amount of current.
I would have been surprised if it spread all the way
It certainly
through.
burned through quickly. I was hoping it would explode or something. Oh well. The current there was higher, a peak of 15,000 amps. Now
Oh,
that's probably near the limit without making some modifications to the circuit. Now if I can do 15 kiloamps for a few seconds, now that would be pretty crazy. And it might be possible with this 3/4 inch bolt here. Here we go.
yeah, they've been the one to maintain the connection a bit more. Nice.
You know, for as easy as it is for wires to short when you don't want them to, it's been bafflingly difficult to hold a short across these batteries. Everything just keeps blowing out of place. I've tried using all sorts of clamps and different materials, but the results are all the same. Everything breaks contact.
Yeah, you produce a hell of a lot of pressure through doing that too. Like, that's also an effect, or at least a byproduct of magnetic fields, that they do push things through a Lorentz force in a certain direction. So yeah, I don't know whether it needs to have more weight or, well, heavier materials.
Bank is scary. However, its voltage is not. And that's why I can do this and not feel anything.
Yeah.
And besides, at only 15,000 amps, I haven't even hit the current of the average lightning strike yet. Are you
Yeah.
telling me some clouds can do better than 100 car batteries? So, is it time to throw all these batteries in the ocean? Nope, not yet. I think using a higher
Not
voltage
yet.
will overcome these problems. So I rewired the bank for a series parallel arrangement. Now there are chains of 5 batteries in series, then all of those are wired in parallel.
Yo, what did Butterfree doing right there? See, the thing is that he is absolutely unhinged, but I think that out of a lot of like YouTube scientists that I've seen, he might be the one who has the most expertise. At least from what I know, he is the one who has been here the longest, and perhaps also has like the professionalism straight up for doing these things. But again, that's just from the perspective of why I remember watching his stuff like, I want to say 7, perhaps 8 years ago. It's been a while since I've watched Styropyro. Again, the lasers were my introduction to his stuff. Like occasionally, alongside the older gentleman there. What's his name? The one with the guitar.
Please join me for the first time to hear how it sounds. And 1, 2, 3, 4.
Mehdi from Electro Boom. Yes, oh man, he was a delight. He helped me going through some high school stuff by watching his video.
This makes the fully charged bank sit at a little over 60 volts. Let's start the 60 volt experiments with another 3/8 inch steel rod. Here we go.
Oof, okay.
Holy heck, that exploded! The slow-mo shows something astonishing here.
Oh, that's cool.
The rod heated so quickly that its zinc coating boiled
Oh,
off faster
you
than
see-
it could burn.
you see the
And then when
plasma.
the rod finally exploded, it left a cloud of greenish plasma as the zinc vapor reacted with the oxygen in the air.
You can
Luckily,
basically
that its
see
zinc coating
the field, the electric field holding it. You see how it forms around it? Oh, that's beautiful. Wow. I wish that we could get to see these things like in real time back in high school, and in some cases uni as well.
so quickly that its zinc coating boiled off faster than it could burn. And then when the rod finally exploded, it left a cloud of greenish plasma as the zinc vapor reacted with the oxygen in the air.
Nice.
Comparing this to what happened at 12 volts, it's clear there's substantially more current at 60 volts. Sure enough, I clocked a peak of 30,000 amps,
Ooh.
which so happens to be the current of the average lightning strike.
Yeah.
I still think I can do better though. Let's see what happens when I try a 1/2 inch bolt.
Well, the potential is 80, so oh.
Heh, I guess those little clamps weren't enough. I've upgraded to some big boy clamps this time, so hopefully this does the job. I'll take that as a no. Yeah, that bolt really does not want to stay in those blocks. In fact, let's take a look here. Yeah, look at that. It just leaves like a big crater of splattering molten steel and copper. Wow. Let's see if quad clamping it will hold it in place.
Can you imagine just set up at work with this? The arc flash that hits a person to it is insane. And for those who might not know, one of the worst hazards that a person can experience when working with electricity is an arc flash. Basically what it is like an electrical current that passes through like ionized air, in this case here, through the contact of like electrical equipment, corrosion, conductive dust, whatever it might be. You name it, right? Where it basically goes like from either phase to phase or ground to phase moment, where you have like a violent energy being released, and in the form of arc plasma, or plasma arc is the right word here. And we're talking about tens of thousands of degrees Celsius or Fahrenheit, it doesn't matter. And whatever it touches, it is cooked, okay? It's absolutely cooked. And plus there's pressure that comes along with it that usually will like create the look of like an explosion, right? So yeah, it's dangerous. It does a lot of damage.
This was easier at 12 volts. What's going on here? Slow-mo shows the increased current has introduced a new problem. These blocks are getting ripped apart by the gayest force field in physics, the magnetic field. Now what's so gay about magnets? It turns out, opposites don't always attract like you might think.
No.
Yeah, when you consider magnetic dipoles, north attracts south and vice versa. However, if you look at currents that give rise to those fields, you'll see the reverse happens to them. Opposite currents repel, and like currents attract.
Yeah.
Now this has a lot of interesting consequences in physics. It's why lightning pinches itself into a fine streamer. And it's also the basis of experimental Z-pinch fusion reactors.
Oh, Z-pinch are awesome. Like, some of you are likely to know how it is that a fusion reactor works, but in case that you don't, they basically do the job that stars do by cheating. In that stars are obviously supermassive. Excuse me, I have a thing in my eye here. And thus, because of the massive size and the insane amount of heat that they generate at a near constant rate, they can force the nuclei within them to merge together and create heavier nuclei and thus release even a larger amount of energy. So what we've done instead is, of course, to approach it differently. And to my knowledge, there are still only two ways of approaching this, because again, I'm not a nuclear engineer, so pardon me if my explanation might be a little bit simplistic. So essentially the two are magnetic confinement, where strong magnetic fields created by superconducting magnets, and sometimes, I think most of the time, cooled by like helium, right? Liquid helium, mind you, not helium gas. They do squeeze the plasma within the reactor and create the high temperature. The other one would be the inertial confinement, where inertial confinement reactors, where they make use of lasers. Those are pretty freaking fun to look at, where they either make use of like infrared or ultraviolet rays to heat the fuel, like pellets, the round spheres of fuel that you may have seen in nuclear reactors in pictures. And so they make those implode and the fusion then occurs. Now, the process of a Z-pinch is pretty much like he indicated there with lightning, and it's of course the methods of a magnetic confinement, where you have some gas like deuterium or tritium that then run through enough current, will ionize the gas into plasma and will then generate a magnetic field that will pinch the plasma, compress it to within like a fraction of a second, where it reaches temperatures that are like hundreds of millions of degrees Celsius, like insane amount of heat. And of course, the pressure is along with it, then creates this energy that you can then harvest.
In this circuit, it causes the aligned cables to bunch up, while repelling the cables carrying current in the opposite direction, and this is what's ripping apart the copper blocks. In an attempt to fix this issue, I brought in two of the leading experts in crackhead engineering, Alan Pan and the Backyard Scientist.
I know Alan. I haven't watched anything from the Backyard Scientist, but them being called crackhead scientists. Oh, that's fucking good.
So you can see I've already tried blowing this thing up before, but like the current is so gigantic and the magnetic field is so huge that like it doesn't want to stay on the block.
Yeah.
Yeah.
I wanna see what this does.
Yeah. It's like you may not be safe, but like we'll do it. Yeah, we'll do it.
These are, that's like an inch thick copper.
Oh yeah, it's literally an inch thick. We're gonna take this bad boy.
Oh, so that just, oh my god.
But the thing is, these huge clamps, they're not enough. It's not, it's the forces and currents are just so big.
Wait, how about you actually... The one that you can screw when either welding...
Oh yeah. This is completely insane.
This is deranged.
This is like,
It's
this
so
is
bad.
just...
All right, everyone ready?
Yeah. Ready?
All right, here we go.
Oh!
See, it blew out of there again. It blew it out. Do you see that? How that was? Do you see the brown smoke?
Yeah.
That's copper vapor.
Really?
Yeah. Yes.
That was like a firework from
Like it
hell.
all shot out sideways.
Yeah. But the contact broke and like you know.
I like how they're amazed at what is actually going on, and he's more like, hey, the technicality is here, there's something wrong with the apparatus, can you help me fix this? Help me!
Broke in like fraction of a second.
Wait, is it safe to look up close?
Sorta.
So the bolt
Sorta.
is actually still there.
Yeah. So that's the problem here. Is the
It just moves it across like.
yeah. So there's two issues. So it explodes and. But also the magnetic field is all opposing and it yanks it apart. So like it barely held on. Like how would you fix this? Like how would you guys find a way to actually keep things on the block and blow up? How would you do it?
I think I could do it.
How would you do it?
I could do it.
Oh, you could, yeah.
Oh, just
Do it.
Pull it in place, of
Right.
course, yeah.
dude, I don't know. Could you
Oh,
like
man.
just like drill some holes in the copper blocks and like through bolt it to a piece of wood or something like a 2x6 and just force them in
Maybe.
position?
You might be able to.
I feel like you don't want to keep everything in position. I'm scared. Like if
Yeah.
everything was locked down, I'm scared of what could happen.
Sure.
Like
God.
But like I want to see that bolt explode. I
Like
want to see it explode. Yes.
Yeah.
Melt, yeah.
kind of bolted them to a piece of wood, like on the same piece of wood, right?
That's what I was saying.
Yeah. Okay. That's what you were saying.
Oh, so
Yeah.
you have the whole
Yeah, it's
mechanism
like,
and
it's
bolted
like
together.
one piece of wood.
Oh, that's a good idea.
Yeah.
Like I was just expecting like melting and explosive stuff, but not a magnet.
I mean, in a way, if we get some wood involved, we can literally get the lightning strike on a tree analogy, and adding some ice to the entire mixture, we can get some picrete energy out of it and call the whole project Habakkuk. How about that?
That's insane. I do like the block of wood idea.
It's a German word for horror and respect.
Oh yeah.
whatever that word is.
Yeah. Before attempting to bolt everything down to a block of wood, we decided to stick
Wait, like overvældende? Well, in Danish, or overvältiget, or just in English, overwhelming, is quite the word, right? I mean, it is the closest thing that I can think of that would mean both things. Something can be scary, and you can respect its size by its being overwhelming.
a couple cans of 1,2-dimethyl-ethane on the apparatus. All right. You ready for this?
I'm ready. I don't usually wear safety goggles.
You ready?
I'm ready.
All right, here we go. Oh my gosh. Wow.
Crackhead engineering.
I'm gonna clear it off. All right.
Oh, it's gonna spark. Be careful.
Okay. That was all the can.
Wow. We tried sticking a can upright with the hope that it would act like a rocket. It turns out this worked just a little too well. Whoa! It ended right there.
Houston, we have no problems.
These fireballs were cool and all, but they also had the function of clearing out some of that annoying grass out in front of the batteries.
Right.
I went ahead and mounted everything to a big block of wood. Now let's try another 1/2-inch bolt. Here we go. Yeah.
Oh, the wooden idea seemed to work. Well, to a certain degree.
Exploded off of there. Wow.
At least it's
That's
now
terrifying.
yeeting itself
Wow, look at
equally.
the remnants of that bolt there. You're welded on there. Wow, it looks like it took about 1/4 of a second for that to melt through. And yeah, it peaked at over 40,000 amps. That is insane. The slow-mo shows 2 powerful magnetic effects here. There are the cables in back violently pinching themselves into a bundle. And also, there's the broken bolt fragment getting launched outward due to the magnetic forces on it.
Yeah.
Well, if the 1/2-inch bolt melts now, maybe the 3/4-inch bolt will melt too.
It's just how casual the entire thing is.
It melted through. It's funny, because as I keep trying bigger loads, sparks get launched further and further, even beyond where I'm hiding for these shots. I figured these tests
Wow.
would be intense, but they're already beyond my expectations.
It's crazy.
This one's gonna be pretty crazy, I think.
One is?
There's that bismuth.
Oh, the
unit that
bismuth
I couldn't
again,
melt
yeah.
Earlier.
Okay.
Holy heck!
The cloud.
It made a huge mushroom cloud. There's not much of this thing left. It just splattered and vaporized all over the place. Wow. I also managed to spray molten metal on the lenses of 2 of my cameras with that run.
I said.
Oops. At this point in the video, pretty much all the footage is terrifying.
I'm very surprised that the equipment has been sticking around so far.
But even so, this is probably the scariest shot so far. The batteries managed to take nearly an entire kilogram of metal and turn it into a cloud of vapor and liquid in a second. The droplets being shot out are so hot that they're burning in air, leaving little trails of smoke while raining burning molten metal on everything around it. Afterwards, I found bits of metal splattered on the trees, the sides of my shop, and even the table I was hiding behind. The impressive pyrotechnic display of the bismuth convinced me to try a stick of titanium as well.
Let's go. Okay, well that is
Titanium is used in fireworks for making bright white sparks.
Yeah.
And it turns out, it makes these beautiful sparks when being zapped by 100 car batteries as well. Who would have guessed? In engineering, there's something called a crowbar circuit.
No. The very first thing that sprang to my mind, this man was like, crowbar circuit, let's do it literally. Of course, his inner Gordon Freeman could not help himself.
And it's used to prevent an overvoltage from killing the rest of the device.
Yeah.
Now, in God's name, because it shorts the power supply, much like if you were to take a crowbar and throw it across the power rails. Now, I think it'd be fun to try the literal interpretation of this circuit. I decided to start with a smaller crowbar here first. Here we go.
Damn.
Holy heck. It like came all the way back here. I had to dodge it. This one gave a really cool oscillating effect as the crowbar kept breaking and then regaining contact, which made the resulting explosions especially violent. I threw in the bigger crowbar and this one burned through even faster. Here we go. Oh wow, the head of that crowbar. Oh my gosh, I just stepped on that and about burned through my shoe. Jeez. Oh yeah, that's hot. Well anyway, I was saying how the head of that crowbar there is just welded onto that. It's flattened and melted down. It's insane.
Anyway, I
I tossed
almost
some
burned my
magnets in the middle of
foot.
the wire loop there, and you can see them jump once the current starts. And yeah, I put my camera way too close for this shot. Now something that sticks out to me here is when the crowbar finally burns through, and it shoots out a big plasma fireball.
Oh.
My bet is that inductive kickback is playing a role here.
Oh, the sudden increase
I
of
figure
the
zapping a
current
couple
when it's
wrenches ought to be
interrupted.
fun.
Right.
Where's the leak, ma'am? Let's start with a small one.
Alright, here we go.
Scheiße.
This big one should be nice and scary.
Okay.
Wow, that one got real toasty.
Oh.
Look how
Oh,
welded
the
that thing
melted.
is on
Oh,
there.
jeez.
Right here I have the biggest bolt that I could find at the hardware store. It's an inch in diameter and 10 inches long. I think this should be fun to zap with the car batteries.
What are they using the
This is going
for?
to be
Trains?
crazy. I hope those clamps survive.
Did that melt all the way through?
Doubt it.
So, it just melted the steel around the threads there. That's crazy. I didn't see that happen with the smaller bolts. So that's what kept it from melting all the way through. It's just floating in the middle.
All right, I'm gonna try it with the without the nut, just the bare bolt in there.
Here we go.
The snap.
Whoa! That was so loud. I don't even know what exploded there.
The final
It was
snap
the
was
fuses
beautiful.
that blew.
Oh!
Look at that. They melted straight through. Wow, that drew over 45,000 amps, and it did it for over a second. Well, at least before the fuses exploded. That is bonkers. I'm actually glad that the fuses exploded here, because it gives a cross-reference for the currents I'm measuring. The Priest fuse current equation predicts that a bank of 10 6-gauge wires in parallel will last a second at 50,000 amps before exploding.
I wish
That's
it
pretty
did.
much what I just saw. I'm only surprised how loud it was. I upgraded the fuses to 4-gauge, but at this point the batteries are really being abused. So I'm going to do some other experiments before trying the big bolt again. You're probably wondering how well this battery bank works as a plasma cutter. Well, I am too, honestly. There's only one way to find out.
Oh no. Oh no. Oh no. This man disdain for microwaves.
That works even better than I expected.
It's an affront to the machine god. Gee.
Yeah, I think that'll do it.
So basically, for every 40k fans out there, Warhammer 40k, your average Space Marine needs to carry something that generates the voltage and amps of 100 car batteries to actually drive the power sword. Just so you know. Madman.
Wow. Wow. That was wild. I think it's time to revisit the huge bolt that I couldn't melt
Finally.
earlier.
All
I
right,
hit the
I've
big
got
boy.
a fresh new 1-inch bolt in there. Hopefully this time will be the charm.
Here we go.
Oh, the clamp's moved, but it's still there. Might have actually burned all the way through this time.
Oh, it melted.
Oh, look at that. It finally burned through. Wow. There's so much heat coming off of that right now. Yeah, I'm pretty sure the radiation coming off of that bolt lit that wood on fire. Wow. That thing got hot.
I clocked a peak of just a hair under 50,000 amps there. That's quite a bit more than the average lightning strike, and for a much
What's the
longer duration
wattage?
too.
What's the wattage?
Total circuit power there was on the order of 3 megawatts.
You should not be measuring anything in mega for video, Drake.
I don't know. I think it's pretty cool.
Who gave you these batteries?
Any desk. Yeah. It was their idea. It's insane. That's right. This video is sponsored by AnyDesk. In fact, this entire video was their idea.
The best
Definitely
sponsorship
makes them
ever.
my coolest sponsor. So, what is AnyDesk? AnyDesk gives you lightning fast connection to all your devices. For example, I don't even need to be near this terrifying battery bank when I want to blow something up with it. I can walk into an Arby's 1,000 miles from my lab and remotely fire the batteries in a tiny fraction of a second.
Ow, for fuck's sake, I'm an idiot. I literally got injured the other day while working in my backyard, so doing that was not the smartest move.
I love the future. As a whole, the engineering for this project was deceivingly complicated. My channel has a history of circuits that operate much more complex than the schematic would lead you to believe, and this one takes the cake for that. I mean, it's basically the first circuit you see in
Yeah,
electronics
it's straightforward.
class. And just a battery, switch, and resistor. Now, of course, there's a
Every
lot
single
more
component.
resistances in reality. The cables have resistance, the switch has resistance, there's contact resistance, even the batteries themselves have an internal resistance. Now, none of this is easy to measure without just building the whole circuit and putting a huge amount of current through it. In the all-parallel arrangement, I couldn't get past 15,000 amps, and I was really disappointed by this. Where was the resistance coming from? The battery resistance is negligible here, and it's not the cables either. I'm using the thickest wire in the American wire gauge system, and I'm running 10 of those in parallel. Now, as a side note, there's no measurement that's more American than the American wire
Rules
gauge.
of thumb.
Anyway, the resistance was nearly all in the contact points, and rewiring the bank for 60 volts was able to overcome most of that. In this arrangement, the limiting factor is the battery internal resistance, which means that most of the circuit power is actually going into heating the batteries. I scoped the voltage across a bolt when zapping it, and it dropped to 6 volts. Yikes. Now, the hardest part about this project was actually coming up with a switch. So, I mean, you can't just buy a switch like this that can, disconnect these huge currents, at least for less than you'd pay for all these batteries. So, my original intention was to build a solid-state switch using, like, a huge array of MOSFETs. I realized that would probably have a really high chance of catastrophic failure. So, I nerd-sniped the members of my Discord server with the hopes that they would come up with a solution. This
Which
was
they
a
did.
unique challenge, but I got a lot of creative ideas ranging from MOSFETs to mechanical devices, and even a cursed mercury switch. The Tesla coil master Greg Lay suggested something hydraulic, which gave me the idea to modify a log splitter. I bought a cheap log splitter and some monstrous copper plates, and then brought them to my friend Josh to weld them up. It was his idea to use the internal spring mechanism to switch it on, which significantly helped keep the switch resistance low when firing. As a side note, this is the same Josh in my early pyro experiment videos that predate my YouTube channel.
Wow, that's friendship for you. Sticking through thick and thin. That's nice.
Yeah, thanks to Josh for building the switch. Thanks to my Discord.
No, he actually meant doing it.
And thanks to AnyDesk for both sponsoring this video and giving me the video idea in the first place. Finally, I'd like to give an ode to the lead acid battery.
No.
These things are tough as nails, invented way back in 1859, making them the oldest rechargeable battery technology.
Madman. Ending a video on a shed post is wonderful, obviously. I will assume that this is not for real, because you know the true reason. He's trying to recharge the electric eels. Oh, that was nice. The yeet switch. I'm sorry, that's gonna get stuck in my head for the rest of the day. Guys, thank you so much for checking out this video. As always, if you liked it, don't forget to make sure to go and subscribe to Styropyro, and of course, subscribe to the channel if you want to. That being said, wish you all to have a wonderful day. See you guys in the next one. Bye.